these plates uplifted a massive section of seafloor. It created tsunami waves that radiated outward, moving through deep water at the speed of a jet plane. By the time the waves reached shore, some were as tall as a 5-story building. 250,000 people lost their lives. The ocean's overwhelming power reverberated across the globe. The water in the ocean is constantly moving. Every drop of water is connected. Imagine dropping yellow rubber duckies at different points all across the ocean. In a month's time, some duckies will travel great distances. Others will only creep along. At first, their movements seem chaotic, but underlying the confusion is a very complex system of surface currents. These currents, seen here in yellow, are driven primarily by the force of winds. Slightly deeper currents, seen here in red, act like rivers within the ocean, flowing more steadily in a specific direction. These currents affect our weather. The Gulf Stream in the northwestern mid-Atlantic and the Kuroshio in the Pacific move warm water from the tropics to the North Pole. For centuries, equatorial currents in the Atlantic, Pacific, and Indian Ocean basins have carried sailors across the globe. These currents, along with the trade winds, influenced history by shaping trade routes between continents. They helped bring Christopher Columbus to America. The circumpolar current around Antarctica is unusual because it makes a complete circle around that continent. This current keeps Antarctica isolated from the rest of the globe and helps keep it even colder than the Arctic. A third level of currents, seen here in purple, moves slowly thousands of meters below the surface. 90% of all the water movement in the ocean occurs at these depths. Put all the currents together, and you see a mosaic of moving water. A mosaic that moves heat and nutrients across the globe. Scientists simplify the mosaic into a model called the ocean conveyor belt. In this model, deep cold currents are shown in blue, and warmer surface currents in red. The conveyor belt begins in the Atlantic near the North Pole. Deep cold water travels south toward Antarctica. Then, the cold water rises back towards the surface and gets warmer. The warmer currents return north toward the Arctic, where the cycle begins again. It all sounds fast, but in fact, the journey can take as long as 1,000 years. We call the ocean by many names: Atlantic, Pacific, Indian, but it's really one massive body of water, a global system connected by currents. Without the ocean, Earth would be a very different place. A furnace by day and freezing by night. Every day, Earth gets bathed in heat from the sun. Water in the ocean absorbs most of that heat. In this view of Earth, we're looking at sea surface temperatures over a 2-year period. Red is warm, blue is cool. The closer to the equator, the warmer the water. Warm ocean water can trigger violent storms. Depending on their geographical location, these violent storms go by different names: hurricane, cyclone, or typhoon. But they are the same powerful phenomenon, with a spiral shape and a central eye. Let's dissect just 1 month in the planet's history. On one side of the globe, Hurricane Katrina devastated the southern United States. While at the same time, on the other side, Typhoon Nabi pummeled Japan. Violent winds tore apart buildings, highways battered shorelines. Heavy rains triggered massive flooding inland. As the storms spent their fury, property worth billions of dollars was destroyed. Hundreds of thousands of people were made homeless, and thousands lost their lives. Changes in sea surface temperatures affect weather patterns worldwide. The most well-known example is a naturally occurring cycle called El Niño, La Niña. El Niño happens when there is a warming in sea surface temperatures across the eastern equatorial Pacific. La Niña is the opposite, a cooling in these sea surface temperatures. This cycle affects weather from Indonesia to the west coast of South Africa, a distance nearly halfway around the world. The cycle brings droughts to some areas and heavy rains to others. Ours is an ocean planet. The interplay of water and atmosphere shapes our weather and our climate, making all life possible on Earth.
Oh,